Well, in this exercise here, we have a set which contains 6 functions, right? These are functions which are defined in a subset of R, which may be R or maybe R except some point, right? For instance, this one is not defined in 0, this one is not defined in 1, etc. And the value it takes, they take is R real values, right? These are the 6 functions we have to deal with, and what we have to do now is to prove that D is a function composition. The D with function composition is a non-abelian group, right? Okay. Well, we need to check 2 things because the function composition is associative, so we don't have to worry about this property here. Okay, and also the identity is easy to spot. Here we have the identity function, this function, so the identity is f1, right? This function composed with any other gives us the other function, right? So that's the identity. So we don't have to worry about these 2 properties. What we have to worry about is about 2 things. First, we need to check that function composition is closed in this set, right? So if you compose any pair of 2 functions here, you get another function here. And once you do that, you have to realize that every function has a unique inverse here in the set, right? All right. So for that, we have to construct the Cayley table, right? And the Cayley table is going to be some table like this, where you put here composition of functions, and then you copy here all the functions, f2, f3, f4, f5, f6, and you have here the same thing, f1, f2, f3, f4, f5, f6, right? And well, the first row and first column are trivial because f1 is the identity, so this is just f1, f2, f3, f4, f5, and f6, and so are these ones, f3, f4, f5, and f6. Okay, so what we have to do is to do the composition of all the others. So we have to focus on these ones, right? So this requires quite some work. So let's do that. Let's compose f2, so f2 compose with f3, right? Okay, so this function is going to be f2 of f3 of x, and that is 1 over f3 of x, because f2 is just 1 over x, and that is 1 over 1 minus x, okay, because that's what f3 is, and that is f4. So here in this first place, what we have is the, in this place we have f4, okay. I forgot to compose f2 with itself, right? We have to do that, of course, but this is 1 over f2, okay, and f2 is 1 over x, so this is just x, and this is f1, so we have f1 here, okay. Good, because now we know that f2 is its own inverse. Now we compose f2 with f4, so f2 with f4 is equal to 1 over f4, and you see f4 here, this is then 1 minus x, and 1 minus x is f3. Alright, so this one here is f3. Now we have to compose f2 with f5, so that's 1 over f5, which is, well, x over x minus 1, and that is f6. Okay, so that's f6. And finally, f2 composed with f6 is 1 over f6. And given f6 here, this is this, which is f5. f5. Okay, good. Right? Now we have to do the same with f3. Unfortunately, this composition is not abelian, so if it were, we would have automatically once you fill a row, you can fill a column, but that's not the case here. Okay, so we have to do it one by one. So let's go to f3 now. So if you compose f3 with g, right, whatever g is, the result is, well, f3 is this, is 1 minus g. So now we have to substitute g in all the cases. So f3 composed with f4 is, well, 1 minus f4, 1 minus f4 is 1 minus this. Okay, and if you reduce to common fraction, this multiplied by that is 1 minus x minus 1 divided by 1 minus x. This is minus x over 1 minus x, which is x over x minus 1. And if we go to here, we see that this is f6. So this is f6. f3, f4 is f6. Well, and don't know why I started by this. We have first to do with f2, right? So that is 1 minus f2 is this, 1 over x, which is x minus 1 over x, and that is f5. So you have here f5, okay? Then the next one is f3 with f3, all right? This is 1 minus f3, but f3 is 1 minus x. So this is just x, so it's f1. So f3 is its own inverse as well, right? Then we have to compose f3 with f5, okay? And that gives 1 minus f5 is this one, x minus 1 over x. Multiply, you get x minus x plus 1 over x, and you cancel the x and get 1 over x. 1 over x is f2, right? And f3 by, well, composed with f6 is 1 minus f6, so 1 minus x over x minus 1, that's x minus 1 minus x over x minus 1, which is minus 1 over x minus 1, or 1 over 1 minus x, and that is f4. Okay, good. And then we have another row here. So far so good, because as you can see, the entries are not repeated. Well, the entries, all the entries are in the set, okay? So the composition so far is closed, right? And you can see that the entries never repeat, okay? And neither they do in the columns, okay? So that's going well. So the next one is F4, right? So let's see what F4 composed with G makes. F4 is equal to this, so what we have to do is this operation with any function. Okay, so let's begin with 2, right? Composed with F2. So this is 1 over 1 minus, and then F2 is 1 over x. Okay, so if we multiply this here and put the x up here, we have x over x minus 1, which is F6. So this is F6. We compose F4 with F3. 1 over 1 minus F3 is this, is 1 minus x. So this is 1 over x, which is F2. Okay. We compose with F4, right? That is 1 over 1 minus F4 is 1 over 1 minus x. So that is equal to 1 minus x over 1 minus x minus 1. So this is x minus 1 over x. And that is F5. We compose with F5, right? This is 1 over 1 minus F5, which is x minus 1 over x. That is x divided by x minus x plus 1, which is x. So this is F1. So F4 and F5 are their own inverses. So that now we don't have to do this one, right? Because we know that this one has to be F1 too, because if the composition of these two functions is the identity, the composition of the reverse composition of the same functions gives you the identity too. So these two are the identity, right? And finally, we have to compose F4 with F6. That is 1 over 1 minus, and F6 is this, so x over x minus 1. That is x minus 1 over x minus 1 minus x, which is 1 minus x, and that is f3. All right, no repetitions, that's okay. So let's go to the next one. Okay, the next one is f5. f5 composed with g is, well, here's f5, so it's g, well, actually, let me just put it this way. X divided by x is 1, so it's 1 minus 1 over x, so is this, right? And let's try to figure out what it is when we compose it with all the others. So f5 composed with f2 is 1 minus, well, f2 is 1 over x, so it's x, and that is f3. Then we compose f5 with f3, and we obtain 1 minus 1 over f3, which is this, 1 minus x. Okay, we multiply it and get 1 minus x minus 1 over 1 minus x, cancel the ones, and you have a minus here, so you just reverse the denominator. Okay, so you have this function, which is f6, composed with, no need to compose it with f4, as I said before, so we compose it with itself. That is 1 over, well, actually the reciprocal of f5, which is x over x minus 1. Okay, so this is x minus 1 minus x over x minus 1, which is 1 over, after you cancel this and use the minus to change this 2, you get this, and this function is f4. And finally you compose with f6, right? This is f6, so this is 1 minus, we reverse this, right, like this, and then we have x minus x plus 1 over x, and that is, after you cancel, 1 over x, which is f2. Again, you can see no repetition, and the only products we obtain are elements which are already in G. Finally, we have to repeat the same story with f6. Okay, so f6 composed with G, whatever G is, gives, this is f6, so it's G over G minus 1. This is going to take a bit more work. All right, so let's do f6 with, yep, let's go f6 with f2, sorry, f2, x. Okay, f2 is 1 over x up here, down here is 1 over x minus 1, all right? So we've got to, actually, I'm thinking maybe it's easier if we write this, we divide the numerator and the denominator by g, so we write this just like this. Might be easier to calculate. Okay, let's do it this way. So what we have is 1 over 1 minus, and here g is f2, so f2 is this, so the reciprocal is x, and this one here is f4. So we have f4 here. Then we compose f6 with f3. We apply the same thing, right? f3 is equal to this, so the reciprocal will be this. Okay, so we cross multiply, and we get 1 minus x over 1 minus x minus 1. Cancel this, use the minus here, and then you have this, which is f5. All right, then compose f6 with f4, and then we get 1 over 1 minus f4 is this, so it's the reciprocal of this is 1 minus x, and that is just 1 over x, and that is f2. All right, then you compose it with f5 as 1 over 1 minus x minus 1 over, no, sorry, x over x minus 1, okay, for x minus 1, okay, and then multiply this, we get x minus 1 divided by x minus 1 minus x. You cancel the x, so that's 1 minus x, which is f3. And the last one, let me do it here. Last one is f6 with itself, f6. That is 1 over 1 minus the reciprocal of this. Okay, so that's x minus 1 over x. And that is x over x minus x plus 1. And that is, of course, the identity, x. So this is 1, and f6 is also its own inverse. So we complete this way the Cayley table. And as we can see, the composition is closed in this set. I mean, all that we obtain when we compose in any pair of functions in this set is another function on the same set, right? And we can see that there is an f1 in every row and column, which means that every function has its own inverse. So this is a group. Also, you can see that there's no symmetry. F4 and F5 are different here. Okay, so there's no symmetry with respect to this diagonal. Therefore, this is a non-abelian group.